Hi everyone, thank you for your interest in this presentation. My name is Thiago Guardia and today I will be talking about Beehive air therapy, from identifying chemical compounds to evidence-based clinical practice. And before I start, I'd like to thank the organizers for inviting me to give this presentation here. For me, it's an honor to be collaborating to the International Apitherapy Congress as a speaker. So thank you very much, and without any other ado, let's get started. This presentation is divided into two parts. First, I will be reviewing a couple of studies on characterizing the chemical compounds of the air of beehives, and then I will highlight the importance of conducting clinical studies for the sake of making this therapy recognized by modern medicine. In this first part, I'll be sharing the main results of two studies that have made some contributions to the understanding of the chemical composition of the air of beehives. The first study is a pilot research I conducted with some colleagues in Brazil in 2017 with the goal of making contributions to the first steps toward characterizing the chemical composition of the air of beehives. The results of this study have been already presented in the Apmondia Congress in 2018, and here I will be reviewing these results with you. And the second study is a more recent research, and in which the article has been published this current year, so 2021. This study is super relevant to the area, in my opinion, because it has not only identified several volatile components of the air of beehives, but also demonstrated the antimicrobial effects of beehives' air, which is a very important step for making this therapy recognized by modern medicine. Regarding the methods of the first study, three different types of instruments that are commonly used in analysis of gases research have been used to collect and store the air of beehives. The first one on the left is a glass air sampling bottle. The second on the right is a glass tube containing activated carbon inside of it. And the third, also in the same picture on the right, is a glass tube containing a material called Tannax inside of it. Both carbon and Tannax absorb the volatile components that can be further extracted by extraction solvents. In total, 7 samples were collected using different approaches. In addition to the storage apparatus, other items that we have considered to develop our method of collecting and storing the air of beehives were: first, collecting time, which is how long the material is exposed to the air of beehive, and then type of extraction solvent for the samples collected in the tubes. Then, 24 hours after the collection phase, the samples of the beehive's air were injected into the gas chromatography and mass spectrometry system in order to be analyzed. There's a lot of technology in these methods, and here I'll only explain their main steps, aiming to facilitate the understanding of our results. In step 1, the samples are injected in this system. In this case, each sample has a separate run of analysis. In step 2, the sample goes into a column where it is gradually heated and the volatile compounds are kept circulating there by a carrier gas. What happens is that each volatile compound has different chemical properties, so each compound reacts differently to the temperature variation and interacts differently to the column coat. Then, in the end, each compound goes out of the system in a specific retention time, and so they get separated based on their chemical properties. In the third step, each compound is broken at the atomic level, which then allow them to be potentially identified. Now I'm going to talk about the results. Here, this figure on the left shows the chromatographic profile of each one of our samples. And as we can see, the sample tube 1, highlighted with a red square, showed a more variety and better isolated compounds, represented by the peaks at the very right portion of the spectrum. So, considering that our first goal in this pilot study was to develop a method for collecting and analyzing the air of beehives, we have that as one of our results that using activated carbon in glass tubes subjected to a constant airflow for 10 minutes and further extraction in dichloromethane was the most effective method for isolating volatile compounds of the beehive's air. The next step was to analyze the chemical profile of each one of the compounds we found in the selected sample. Thus, as a second result of this study, we got the chemical profile of each one of the 15 volatile compounds that we could separate from the beehive's air. And this table in the center shows what the chemical profile of each one of the compounds we found look like. Then, as a final result of our study, for each one of the compounds we have isolated, we got a list of the 25 most likely chemical identification. So, different molecules that matched the molecular profile of each one of the compounds we have separated. In this slide on the left, there is an example which is showing the 3 most likely identification for the first 4 compounds. And that is the farthest point we went with this pilot study. To recap, first we isolated 15 volatile compounds from the beehive's air, and we end up having a list of 25 most likely identification for each one of those compounds associated with their formulas and chemical categories. Remember that this was a pilot study, and for a complete identification of the compounds, more samples and more run-of analysis would be required. Then, in this second study, which was developed by researchers from different countries, is a more advanced study and has also a more precise result. This study has evaluated the volatile compounds of the air of the beehive and other products of the hive, as shown in the left portion of the slide. And as a result, this study has identified 56 volatile compounds, from which 44 had never been reported before. So I consider this study a substantial contribution to the area of the beehive's air therapy. Additionally, this study also showed that the air of the hive has antimicrobial properties, which was tested against different types of bacteria that can affect the respiratory system. And based in their results, the authors of this study suggested that the air of the beehives could potentially be used to treat respiratory disorders. However, clinical studies are still necessary to confirm this. And that brings us to the last part of my presentation, which is highlighting the importance of conducting clinical trials to test the efficiency and safety of the beehive air therapy. Translational science is the segment of science which helps translate scientific findings into validated health products or services. And this translation from science to practice in healthcare happens through a series of phases. I won't get in the details of that here, but essentially a basic scientific finding needs to be validated by clinical trials before being approved by health authorities. And promoting clinical practice without an evidence validated by science can lead to potential problems or restrictions to the practice, such as, for example, what happened a few years ago in Germany when health authorities banned the practice of beehive air therapy because there was no scientific proof that the technique was effective or even safe. I'm not sure what is the current legal status of the practice around the world at this moment, but the beehive air therapy, as the beehive air therapy becomes more popular, it also will call more attention from the health authorities, which of course will require scientific evidence before acknowledging and thus supporting this therapy. And that's why here I'm highlighting the importance and necessity of conducting a series of clinical trials to evaluate the efficacy and safety of the beehive air therapy. And the idea is to create a group of interested researchers, healthcare practitioners, and apitherapy centers that offer beehive air therapy, so we can organize an international multi-centered study on beehive air therapy. If you are interested in participating or contributing to this initiative, please contact me. Let's organize a group, find resources, and make this study happen. So far, in addition to myself, there are already 3 potential collaborators that demonstrated interest in developing this study. There is the Apitherapy Wellness Center in Canada and a partner in Brazil that offer beehive air therapy and are interested in collaborating. Additionally, I also have talked with a researcher from Brazil who has given me a positive feedback, signaling that we could potentially get a support from the Faculty of Medicine of the university that she works at. I can't share the details yet, but until it becomes official, but that is a very promising possibility. Again, if you are interested in contributing to this study, please contact me. Let's collaborate and make the beehive air therapy recognized with science proof. And that concludes my presentation. Thank you very much for your attention. My email is tiago.guardia@gmail.com. Please contact me if you want, and just let me know if you have any questions. Thank you very much.